Hello, sir.
Hello, how are you?
Good, sir.
Good, amazing. So I am requesting everyone, if your cameras are working, please turn them on so that I can see you who I'm talking to. I'll be more comfortable that way. So we have 5 people so far, and it's 7:09. Do you have your math notebooks or something with you to take notes?
Yes, sir.
Great. So what do you guys like? What's your favorite subject? I'm sure it won't be maths, or is
Social
it?
studies for me.
Social studies. Okay, what about others?
Me as well, sir.
Social studies.
Yes.
Oh, okay. Okay. So, and others? Edmund, others?
Science.
Oh, science. Great. What about you, Sangpui, Zononi?
Oh, sorry. Sorry, sir. Could you repeat that?
I was just asking, what's your favorite subject?
Oh, my favorite subject is probably English or science.
Oh, okay. Great. So, no fan of maths here.
Yes.
Wow, that's sad. So, okay. So, let me first of all introduce myself. Hi, everyone. I'm Anmol, and I have been teaching maths. I've been creating content for maths for past 7 to 8 years. So, I love maths, by the way, and I like to teach it to my students. And my only vision is what I want to do is to ensure that okay, you have proper visibility, proper understanding of the concepts that we would be discussing today. So feel free to ask any questions. I'm not a person who will scold you or for anything. You can ask the questions that you want. You can very bluntly say to me that okay, this is something that I didn't understand even a single word about. So be very open, ask questions, and let's keep the discussion going on. It won't be like a monologue from my side, and let's do that, and let's see if I am able to change your perception towards even one single topic in mathematics. So that will be my aim for today, and I'll ensure that okay, at least your basic understanding of the chapter, ratios and proportion, that's clear. And if that happens, then it's a win-win for both of us. Any questions?
No, sir.
No, sir.
Great, great. So let me know, okay, if there are any connectivity issues, if you're not able to hear me properly, or any feedback during the session, feel free to stop me and give your comments. Okay,
Yes.
fine. So let me now share my screen. So if you can see my screen, right?
Yes, sir.
Yes, sir.
Great. So tell me first of all one thing. How many of you, have heard this topic, ratios and proportions? Or is it like first time you're hearing about this?
First time.
First time. Okay. Others?
I've
Yes,
heard
sir.
of it,
It's the
sir.
first time.
First time.
Same.
Okay, okay, great. So let me try to break it into very simple words that we already know about, right? Because that's how we start building that connection between what you already know and what we will be learning today, the new concept, ratios and proportions. So the basic meaning, I would say, it's let's just imagine a scenario where you have to compare two quantities. I'm sure you would have done comparison, right? Height between siblings, right? Okay, what's your height? What's your brother's or sister's height? Or maybe how tall an object is, how short an object is. Small comparisons we used to do in our day-to-day life, right? For example, let's say that I have one tree one, which is let's say 10 meters long. Okay, we have our first tree which is 10 meters long, and then we have our second tree which is let's say 6 or let's say 5 meters tall. Okay, simple scenario. This is my tree one, this is my tree two. Now if I'll ask you, how much longer is tree one than tree two, what will be your answer?
5 meters longer.
5 meters longer, right?
Meters.
Absolutely right, because this is 10. This is 5. If the question is around how longer or how like how taller is tree 1 greater than 2, then I'll just take the difference and this will be 5 meters. So I can say that tree 1 is 5 meters longer than tree 2. Understood? You're with me so far?
Yes, sir.
Sir.
Okay.
Yes, sir.
Now let's change the scenario a bit. Let's say my object 1 is a big table. Okay, let's say a big table. And the length of this table is somewhere around, let's say, 600 centimeters. Okay, the length of this table is 600 centimeters. And my object 2 is, let's say, a small pencil, just a small pencil, which is, let's say, just 5 centimeters longer. Now just imagine if we want to compare the lengths of these two objects, the length of the table and the length of the pencil, will it be justice if I'll say that, okay, 600 centimeters, the length of the table is 595 centimeters more than length of the pencil? That's one way to say it, right? If I'll just take the difference. But generally when we compare a very big object with a very smaller one, just think about the weight of an elephant with the weight of an ant, that type of a comparison where the objects are at extreme ends, then taking the difference for the comparison like we did in our first scenario doesn't make sense. It doesn't give me that perception. So for that reason, what I will do, I will, instead of subtracting, I will divide them. For example, if the length of this table is 600 centimeters and the length of this pencil is 5 centimeters, if I will divide 600 by 5, this will be equal to 120, right? 600 by 5 is 120. So I can say this table is 120 times longer than the pencil. Now that gives you a sense of perception, how big that table is compared to the length of pencil, right? Or in other words, I can say that if I have 120 pencils that are 5 centimeter long, I can stack them up together to get to the length of the table. That is where we use ratios to compare such quantities. You can do it by taking difference between the lengths. That's fair. No issues. It's not wrong. But when you want to build a perception around how big an object is, and compare it with very smaller objects, then we use the concept of ratios where we divide two quantities. Right? So what we did here, we divided the length of this table 600 centimeters with the length of pencil, which is 5 centimeters. And after division, I got a value 120. This means that I need 120 such pencils to cover my entire table. So for example, if this is 5 centimeters long, so I'll stack 120 such pencils like this to get to the length of the table. So if this is my pencil, which is 5 centimeters long, now I can generate a perception about the table that, okay, if I'll stack 120 such pencils, that would be the length of the table that I'm talking about. And that is where we compare it like this. And that is where we come across the concept of a ratio. So ratio is nothing but comparing two objects. It can be their lengths, it can be their weights, it can be their volumes, it can be anything. But to build that sense of perception, we use ratios to compare two quantities. Is it okay? I'm too fast, too slow?
No, sir.
Clear?
Yes, sir.
Okay, so let me take one more example. Let's say that, for example, someone else is joining. Okay, so let's take one example. Okay, that we just talked about, that we have an elephant. Sorry for my bar diagram. Let's say this this is my elephant. Okay, and the weight of this elephant is, let's say, 500 kgs. It's a mini elephant. Okay, so 500 kgs. And then I have a small, let's say, what's the other? Let's say I have a cat. A small cat that just weighs 2 kg. Okay, the weight of this cat is 2 kgs. Now, can you tell me what is the ratio between the weight of the elephant and the weight of the cat? Or how many cats? So just think of it this way: is that you have a weighing scale, and somehow in your imaginative world, you are able to place the elephant on one side of the scale. Just imagine, okay? On one side you have the elephant, and one side you can have a lot of cats of 2 kgs weight. So how many cats should you place here such that it balances the weight of the elephant?
250 cats.
250 cats. Okay, so I have one answer, 250. Any other answers? Come on, come on. Any other answers?
Sir, I got 250 as well.
Okay, so we have two answers for 250. Others?
So my answer is 250 as well.
Amazing. Okay, so we have one more here. Come on, others. No? Okay. So 250 is the right answer. So great, great job. So this means that I should have 250 cats on this side of the weighing scale such that it balances out the weight of the elephant. And that is, in simple terms, in mathematical terms, ratio. That the ratio between the weight of the elephant to the weight of the cat is 250. And how did we get this 250? Weight of elephant is 500 kg and weight of cat is 2 kg. So 500 divided by 2 is 250. Now you'll get a sense of how you can compare the weights. So let's say that you have your own you have your cat as your pet. So you can compare that if you'll have 250 such cats weighing 2 kgs, that will be equivalent to the weight of one elephant that we are talking about here. So ratio is a beautiful concept that helps you compare two quantities, to objects, weights, lengths, volumes, etc. So do you get now do you have like a perception of what is ratio? What do you mean by ratio?
Yes, sir.
Yes, sir.
Okay. Any doubts so far?
No.
No, sir. No, sir.
Okay, great. So let's shall we try a few questions, few basic questions on this?
Yes, sir.
Okay, great. So let me show you first question. Can you try question number 20? The last one. There are 50 boys and 30 girls in a class. Which of the following is the ratio of the number of boys to the number of girls in the class? And you have four options. Don't worry about whether your answers are correct, incorrect, it doesn't matter. If you have any doubts at any of
Yeah.
the steps, do let me know.
My answer is C, 5:3.
Okay, great. We have one answer, but I want answers from all of you.
Mine is C as well. Yes, sir.
Oh,
See,
so we have three votes for option C. Anyone getting different answer?
Sir, my answer isn't an option there.
What are you getting?
I got 5/3.
5/3. Okay, okay. No issues. Okay, I like your honesty. What about others? I'll tell you, you have your answer with you. It's all about how you visualize 5/3 at 5:3. I'll get there. Any other answers? All of you, please try at least. Okay, so you have your notebooks, keep your pens with you. So maths is all about trying. There is a general perception around maths that whenever you solve a question, especially the difficult ones, there is an expectation from your teachers, from your coaches, that you should get to the correct answer. That's totally wrong. Maths is not at all about getting to the right answers. It's about understanding the process well. If you have the understanding of the concept, like what you are doing, that's more than enough to understand maths. So don't worry about your answers being correct or incorrect. We will learn that together, but just ensure that you have complete clarity on the process. That's what matters. And if you have any doubts, do let me know. I'll be more than happy to, again, repeat the concept, explain it again in detail. Okay, so see, option C is first of all the right answer. So good job. And it says that there are 50 boys and 30 girls in a class, and we need to find the ratio between boys and girls. In other words, in a very simple manner, it's saying that compare the number of boys with number of girls. As simple as that, right? So I have 50 boys with me. I have so I have 50 boys and 30 girls, and I have to compare their numbers. Now, when we are comparing, that's why we use ratio. So here we have 50 and here I have 30. Now the ratio between, the question is, now listen to the language very carefully. Now we are getting a little bit mathematical. Ratio between number of boys to number of girls. That's the question. Now what is number of boys here? 50. And what is number of girls? 30. So the ratio will be, so the ratio that they are asking, ratio between number of boys divided by number of girls will be 50 upon 30. And when you'll divide this by 10, because you can see that it has 10 as its common factor, this will be equal to 5 upon 3, which is what I think Christabel got, 5 upon 3. Now this is same as writing it as 5 is to 3. Both mean exactly the same thing. This two colons, this colon, that symbol that you can see here, this stands for ratio. So irrespective of 5, what your answer is, 5 by 3 or 5 is to 3, it's same thing. This is also equivalent to 5 by 3, which is a right answer. Now, okay, we solved this answer correctly. But now can you just think about, what does this 5 upon 3 mean in terms of the question that was given? Can you explain the answer to me? So 5 is to 3 is the right answer. But what does it exactly mean? I'm just trying to help you build that perception. Okay, 5 is to 3, 5 upon 3 is the right answer. That's the ratio between boys and girls. But if you want to give me that in a very simple language, how would you explain your answer?
Mm,
Please try. There is nothing right or wrong. Just try to get a sense of how would you explain 5 is to 3 to me?
So my answer basically tells that the difference between the boys and the girls, the number between them. So there are 50 boys. There are 5 is to 3 is the difference between the boys and girls.
Okay, that's one way to look at it. Others?
We get the answer 5 is to 3 by cutting 50 and 30 by its common
Right. Okay.
Yeah.
But what does 5 is to 3 stand for? Like, what does that mean? Your process is correct. We got to 5 is to 3, but just help me relate it with the question that's given. Like initially we discussed, right? For example, in the previous example, where we were discussing the weight of an elephant and a cat, we saw that we would require 250 such cats to weigh as equal as the weight of an elephant. Similarly, so that's the meaning of the ratio that we calculated there, 2 is to 1. Now, similarly, we got here 5 is to 3. So just help me build that perception. Like, what is 5 is to 3 here?
So what I understand of this is there are 50 boys and 30 girls, and 5 represents the boys and 3 represents the girls, and this is like um, the difference between them. I think.
Great job at thinking. So let me explain it to you. So first of all, okay, thanks for trying. That's what matters. But okay, so let me address this misconception because this is a very beautiful point, and that's what I wanted to highlight here. So you remember when we started the session, I told you there are two ways to compare, right? For example, when we started initially, this tree example, we compared them using the difference here, right? 10 minus 5. So we can say that tree 1 is 5 meters longer than tree 2. But then we started with our second example when we started comparing them by dividing them. And when we are using division, basically ratios to compare, we say how many times will it fit into each other. For example, if I have 5 centimeter pencils, I would need 120 times such pencils to fit into table's length. So this difference part is gone now. We just have it to compare using the ratios. So coming back to this example of 5 is to 3. So I know this 5 is to 3 is the ratio between number of boys and number of girls. So let me put it this way. Here we have boys and here we have girls. This is 5, this is 3. This is what we got. So this would mean that for every 3 girls, there are 5 boys. So if, just forget about the total numbers. If in the class there were only 3 girls, then there would be 5 boys if we are using the same ratio. Now the beauty is if we will multiply both of them by 2, for let's say that, okay, now number of girls increased to 6, 3 times 2, 6. Then in similar manner, the number of boys will also increase. So number of boys will now be equal to 5 times 2, that is 10. Because my still this ratio for every 5 boys, there are 3 girls, that's still maintained. So for every 6 girls, I can say there are 10 boys. So if you want to check the ratio here, 10 upon 6, you can divide both numerator and denominator by 2. This will again give you 5 upon 3. Right? Okay, let's say that, okay, the number of girls increased 5 times. 3 times 5. Now we have 15 girls. So in similar manner, the number of boys will also increase by 5 times. 5 times 5 is 25. So if there are 15 girls in the class, the number of boys will be 25. Again, same ratio, 25 upon 15. You can divide both numerator and denominator by 5. So 5 5s are 25, 5 3s are 15. You still have the ratio 5 is to 3. So this ratio that you got, this answer that you got here, though it was correct, but I just wanted to tell you that this means that for every 3 girls, there are 5 boys. And how, and just I'll tell you the one final thing here, that if we'll extend the same concept, now we had 30 girls, right? So if I'll multiply 3 with 10, I'll get 30 girls, right? If I'll multiply 3 with 10, I'll get 30 girls in my class. That's given here. So if this relation is true, then the number of boys should be 50. And you will get it as 50. Why? Because 3 times 10 is 30. If we'll multiply 5 times 10 also, the number of boys is 50. So my ratio is still maintained. 50 is to 30, which is divided by 10. 5 is to 3 again. So this is the beauty of ratios. That if you want to maintain the same ratio, you can just extrapolate by multiplying both numerator and denominator by same quantity, and then you can get a perception around that, okay, for example, in this case, if you had 5 boys for every 3 girls, what if the number of girls changed? Then how many boys will be there in the class? And accordingly, using the same ratio, you can find that. Okay, questions? Any questions?
No, sir.
Is that clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, great, great. So fine. Let's try one or two more questions on this. Try question number 19. If the cost of a toffee is 50 paise and the cost of a chocolate is rupees 10. Now remember, both one quantity is in paise, another quantity is in rupees. So when you are dividing, you have to ensure that the quantities are in same units. So either you convert the paise into rupees or you convert rupees into paise and then take the ratio.
Sir, my answer is option A, 5:1.
Okay, so we have one answer for one vote for option A. Others? Nice try. Chalo, okay. Let's try. Let's see what others are getting. Is everyone trying?
Yes, sir.
Okay. At least people with their videos on, I can see them. But for some of you, it's turned off, so I can't see. It makes me really happy seeing that you guys are trying. There were classes that I have, taken that people don't even try. And I'm like, you please try, please try, please try. So great, great that at least all of you are at least trying the questions.
Sir, my answer is number C, option number C.
Again, C. Okay, so we have option C. Okay. Quickly, any other answers?
Sir, I got a totally different number, not from the options.
Okay, what's your answer?
2 by 6. 2:6.
2 is to
Two is
6.
to six.
Sir,
Okay.
I got B.
You got B. One is to who got B? Sorry.
Me, sir.
Okay. Okay. So let's see. Okay, don't worry about your answers. Let's see. Just now I'll tell you the process and just evaluate where did you get wrong. Okay. So see here, we have the cost of one toffee is 50 paise. So let me write that down. And then we have cost of one chocolate is 10 rupees. Now we need to find the ratio between the cost of toffee to the cost of chocolate. Remember, this sequence is very important. The ratio between cost of toffee to the cost of chocolate. Okay, so this is the question. Now, remember I told you that first of all, when taking ratios, when comparing quantities, you need to change them into same units first. Now, the cost of toffee is in paise and the cost of chocolate is in rupees. So, to make it simpler, to make get it into same units, I'll just change this rupees into paise. Now, what's the relation? 1 rupee is equal to how many paise?
100.
100 paise. Amazing. Yeah. So this is the relation that we will be using here. That 1 rupee is equal to 100 paise. So how many paise will be 10 rupees? Can someone tell me?
1,000.
1000. Amazing. Any doubts here? Because 1 rupee is 100 paise, 10 rupees is 1000 paise. And again, if you look carefully, we are using the concept of ratios here to convert this, right? Because 1 rupee is equal to 100 paise. So this means that if we have to maintain this ratio, then like I told before, right? If we are multiplying this with, let's say, 2, if I'm talking about 2 rupees, then I have to multiply this with the same value to maintain that ratio. So 1 times 2 is 2 rupees. 100 times 2 is 200 paise. Right? Similarly, if I'm going for 3 rupees, so 1 times 3 is 3. 100 times 3 is 300 paise. But now I'm looking for 10 rupees. So I have to multiply 1 with 10. So 1 times 10 is 10 rupees. And I have to multiply paise with the same value. So 100 times 10 is 1000 paise. So directly or indirectly, you would be using ratio in a lot of ways in your life, especially in mathematical questions. So that's why developing a good understanding of this concept is really important. Okay, so this is 10 rupees, this is 1000 paise. So now instead of 10 rupees, I'll change it to 1000 paise. Now the cost of one toffee is 50 paise, cost of one chocolate is 1000 paise. Now we need to find the ratio between the cost of toffee to cost of chocolate. So toffee divided by chocolate. Cost of one toffee is 50 paise and cost of one chocolate is 1000 paise. Okay, now let's divide 50 upon 1000. So let me divide both numerator and denominator by 10. Okay, so if I'll divide this by 10, now remember, whatever quantity you're dividing the numerator with, you have to divide the denominator to in the same with the same quantity. Okay, so 50 divided by 10 will give me 5 and 1000 divided by 10 will give me 100. So this is now changed to 5 upon 100. Still, I can simplify this. Okay. Now again, I'll divide both numerator and denominator by 5 because both of them, 5 and 100, have 5 as the common factor. So 5 times 5 divided by 5 is 1 and 100 divided by 5 is 20. So now this ratio is 1 is to 20 between number of toffees and number of chocolates. So therefore, my ratio is 1 upon 20 or 1 is to 20. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Super clear or just clear?
Super clear, sir.
Super
Super
clear.
clear. So can you explain this concept to me? Okay, so 1 is to 20 is our right answer. Now again, what does this mean? This is 1 is to 20. Now let me tell you the meaning of this. Again, what do we mean by 1 is to 20? Can anyone explain? What is the meaning of our answer is right, 1 is to 20. But again, like what is the significance of the answer? Like how can I interpret the answer?
I'm not really sure how to explain it, sir.
Sorry?
I'm not really sure how to explain it, sir.
Okay, fair enough. I like the honesty. Anyone else who want to try? Think hard. No? Any
Yes, sir.
any weird answers are also welcome. Anything that you can imagine or could think of. Don't worry about your answers being wrong or weird or totally incorrect. That's totally fine. And any humorous answers are also welcomed. If you want to just say something out of the blue. Come on, come on. I need something. Give it to me. No?
Yes, sir.
Okay, no problem. Let me explain this. So we have the ratio 1 is to 20, which means that the cost of toffee is this ratio is between cost of one toffee to cost of one chocolate. And the thing that we are comparing is the amount that you will spend to buy a toffee or buy a chocolate. Now 1 is to 20 would mean here that cost of toffee to cost of chocolate, that okay, if you want to buy one chocolate, the price of one chocolate is same as buying price of getting 20 toffees. That is why it's 1 is to 20, right? That the amount that you will spend in buying one chocolate is same as it will be same as the amount that you will be spending towards buying 20 toffees. Is it clear? No,
Yes, sir.
Yes, sir.
right? This toffee is to chocolate, this ratio we are getting as 1 is to 20, right? Which means that the price of 20 toffees is equal to price of one chocolate. That is the meaning of this ratio that we are getting here,
Well, understood, sir.
right? So, you know what you can do? Just try a few more questions related to ratios, right? And the best part is you don't focus on just getting to the answer, but where I would really suggest you to spend some time is to interpret the answers that you are getting. That will help you ensure that you have a good understanding of ratios. Okay,
Yes,
Yes,
sir.
sir.
right? Because the more you'll be able to visualize, the more you'll be able to interpret. I think that will make you really good at this concept. Okay,
Yes, sir.
Yes, sir.
so is this ratio clear? Any doubts
Yes,
so far?
sir.
No, no, sir. Yes, sir.
Are you bored?
No, sir.
Sure.
Yes, sir.
Or do you feel like what is this teacher talking about? I don't know at all. Okay, great. So let's wind up here. I hope this concept is clear for the ratios. Any doubts you have in this concept? Anything that you would like to ask again?
Mm,
No, sir, we
not,
understand.
not really, sir.
No,
Okay,
sir.
okay, great. And any feedback on the session? Did you like it? How did you like it? Did you
Yes,
enjoy?
sir. It was a
Yes,
very
sir. It was very fun,
interesting
sir.
session.
To understand
I
the
learned a lot
Sir,
today.
Oh,
Okay.
wow. That's amazing. Uh,
Yes, sir.
your voices are breaking. Can you tell me one by one? Maybe Annabelle, you can start.
Sir, this was a very enjoyable session. You're a really great teacher, and I feel really comfortable around you.
Oh, thank you. Thank you so much. That means a lot. Thank you. What about others?
Yes, sir. As Annabelle said, you were a very good teacher, and we actually really understand your explanation. So it's a really nice session.
Thank you. Thank you so much.
Um, Thank you for teaching us, and I got to understand better because before I didn't really understand how it was like 1:20 because like this problem I knew how to solve it, but I didn't really understand how to interpret the.
That's amazing. I think I'll cry now. You guys are so awesome. You're giving so much good feedback. Thank you so much for listening to me patiently and learn well. And I'm sure you'll do great. So be confident. And that's it for today. I'll again see you soon. Okay.
Yes, sir.
Enjoy. Stay healthy. Stay safe, and keep smiling.
Yes,
See
sir.
you. Then.
You too, sir.
See
Bye.
you.
Have a good day, sir. Bye bye.
You too. Bye.
Bye.
Good night, sir. Bye.